And we're back. Similarity transformations are the topic of the second lesson in Chapter 7 of the Pearson Geometry video series. Similarity transformations are compositions that contain a dilation, which means the composition will be a combination of a rigid motion, and we talked about those. Those are translations and rotations and reflections, and a dilation. Either way, the result will be the same shape, but either smaller or larger, and possibly facing a different direction. So first we're going to look at how to graph compositions, and then how to identify the similarity transformations, and then whether or not we even have similarity. And then we're going to talk about circular transformations or similar circles. So let's start with how to graph a composition. Okay, so in example 1, the notation tells us that we have a reflection over line M, and M is going to be x equals -3. And then we have a dilation of 0.5, which means our scale factor is 0.5 or 1/2. So what you need to remember in a composition is that the second one always comes first, and the first one always comes second. So we're going to do the dilation first, and then we're going to do the reflection. So this one is already done. So we started out with A, B, C, and to do the dilation, we multiplied each of these ordered pairs by 1/2. So A became 1, 2, B became -1, 4, and C became 0, 5. All right, then we want to do the reflection. And since we know the reflection is over the line x equals -3, we want to put that line right here. So here's x equals -3, it's dashed, which means it's really invisible. So then we're going to reflect A prime, B prime, C prime over x equals -3. So let's start with B. So we're going to count over 1, 2, and then 1, 2. And then A is going to be 1, 2, 3, 4, 1, 2, 3, 4. And then C is 1, 2, 3, 1, 2, 3. So you count over to the line and then that much farther. And then this ends up being A double prime, B double prime, C double prime. And that's our similarity transformation. We're going to practice another couple of those in just a few minutes. Okay, let's take a look at finding similarity transformations. As I said before, a similarity transformation is a composition of a rigid motion and a dilation. So finding similarity transformations means identifying what's happening. So if we take a look at triangle ABC and triangle A prime, B prime, C prime, we can see that this is going like this, okay, and that's a turn, which means it's a rotation. So it's going around like this. And then it's getting bigger. Okay, so what we have here is a rotation and a dilation. Okay, this one right here, this is our original one. These have the prime symbols. So we've got X, Y, W, Z, and it's flipping over and then getting smaller. So this one is going to be a reflection and then a dilation. Okay, in example 3, we're trying to determine whether or not the two figures are going to be similar. So in this case, we're looking at her sketch that she wants to put on a wall. Okay, so the wall is 15 by 20. The sketch is 11 by 14. The wall is measured in feet. The sketch is measured in inches. So the first thing that we want to do is change our feet to inches so that we have similar measurements to compare them to. So if we start with 15 feet and we change that to inches, we're multiplying it by 12. So 15 times 12 is 180. So 15 feet is 180 inches. If we do the same thing with the 20 feet times 12 is going to give us 240 inches. Okay, so we have an 11 by 14 sketch and a 100 by 240 wall. So what we want to do, one of the easiest ways to see if these are actually similar, is to set up a proportion. So we can say 11 over 14 should be equal to 180 over 240. That would mean that the same scale factor is used on both the numerator and the denominator, or the length and the width. So if we cross multiply these, 11 times 240 is going to give us 2,640, and that should be equal to 180 times 14, which is 2,520. Since these numbers are not the same, then these pictures are not similar. Okay, now, last thing on this side, we're going to talk about similar circles. All right, in a transformation, we're talking about a rotation. It's a circular movement. Okay, so if we look at ABC and see how it gets to XYZ, ABC is going to rotate this way, and then it's going to slide over here, and then whoosh, it's going to shrink. Okay, so what are we looking at here? We are looking at a rotation, and then a slide or translation, and then a dilation. Now, I said that these were easy, and they are super easy, because if we're trying to figure out whether circle P is similar to circle Q, what would be your best guess? If your best guess is yes, then that is a very good guess, because all circles are similar. Okay, this is a symbol for similar. It's like without the equal sign, it looks like a congruent. If you leave off the equal sign, then it's similar. Okay, let's take a look at the other side. Okay, so Reese has looked at this composition and determined that it's dilated and then rotated to produce XYZ. So dilated, so shrunk, and then moved around. Okay, so if we look at which ones go with which ones, okay, B goes with Z, C goes with Y, and A goes with X. Okay, so if it's rotated, then that means that C goes here, and B goes here, and A goes all the way around here. Okay, that is not even possible. So if you can kind of visualize what's happening with this, it's going to lead with the C, and so the C would be right here instead of right here. So this is not a rotation. What this is a reflection. So it's reflected and then shrunk. So what we're really looking at here is a reflection and a dilation. Clearly, Reese was not paying attention while she was taking notes. Okay, now let's take a look at example 7. Example 7 is the similarity transformation that I was talking about at the beginning of this video. And what I want you to do is to pause the video and then see if you can do this composition. Start the video back up and check your answer. Okay, keep in mind, this is a rotation 90 degrees around the origin. It does not say that it's clockwise, so that means it's by default counterclockwise. So we're moving from quadrant 1 to quadrant 2 because it's going this way. Okay, and then this is a dilation of 0.5, which means 1/2, and you're going to start with the dilation, multiply all of your numbers times 1/2, and then you're going to proceed to rotate. Okay, so go ahead and pause the video, see if you can do that, and then come back. Okay, first thing that we want to do is put the actual original on here. So we're going to go to 5, 1, that's A, and then -3, 4. So -3, 1, 2, 3, 4. Okay, that's going to be B. And 0, 2. So 0, 2. That's going to be C. And 4, 6. 1, 2, 3, 4, 5, 6. So that's going to be D. Okay, now you want to be kind of precise with this because this is a quadrilateral, but if you're not fairly precise, it's not going to look like one. It's going to look like a triangle. So I'm going to use the protractor. You can use any straight edge that you have handy. When I do these at home, I usually use like a playing card. Ace of spades is my favorite. Okay, so we have our first set. Now we want to do our dilation. Okay, so we're going to cut each one of these in half. So A prime is going to be 2.5 and 0.5. B prime is going to be negative 1.5 and 2. C prime is going to be 0 and 1. And D prime is going to be 2 and 3. I wish they could all be whole numbers. That would make it so much easier. Okay, so 2.5 and 0.5. So 2.5 and 0.5. It's going to be right about there, right smack in the middle of that square. B is going to be negative 1.5, negative 1.5, and 2. Okay, C is going to be 0, 1. And D is going to be 2, 3. 1, 2, 3. Okay, so we have our dilation by 1/2. We'll go ahead and draw those lines and connect those points, which, in case you wondered when you were in kindergarten where you were ever going to use those dot to dots, this is where you're going to use it. Okay, now we want to do the rotation. Okay, so for the rotation, we are going to switch each of these. Okay, so it's going to be 0.5 and 2.5 and 2 and negative 1.5 and 1 and 0 and 3 and 2. Okay, and then we are going to change the sign of the first one. Okay, so A double prime is going to be negative 0.5, 2.5. B double prime is going to be negative 2, negative 1.5. C double prime is going to be negative 1, 0. And D double prime is going to be negative 3 and 2. Okay, so let's go ahead and graph that. So we've got negative 0.5 and 2.5, so right about in there. Okay, and negative 2 and negative 1.5. So negative 2 and negative 1.5 is going to be right about there. Negative 1 and 0 and negative 3 and 2. Okay, so when we connect these, it's going to look something like that. If that's what you got, yay! If it's not what you got, then see if you can figure out where you went awry. Rotations are always difficult, and we haven't done them for a long time. But let's take a look at example 8. Example 8 doesn't have a rotation. Example 8 has a dilation of 3 and a reflection over the x-axis. And if you remember which one comes first, it's going to be the reflection over the x-axis. So go ahead and try that one and then check your answers. And we are going to go ahead and put the original on there. So we're looking at 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. And 1, negative 2. So over 1 and down 2. And back 1 and up 6. 1, 2, 3, 4, 5, 6. Okay, and we're going to connect those points. Okay, and we have a triangle there. All right, now we want to do our reflection first. Okay, so we need, it's over the x-axis. So everything's going to count up to the axis and then that much farther. So for let's see, for 3, 5, so 1, 2, 3, 4, 5, okay, it's going to be 3, negative 5. So we're going to change our signs. So, writing green. So 3, negative 5. So if you're reflecting over the x-axis, you change the sign of the y. If you're reflecting over the y-axis, you change the sign of the x. So that's going to be g prime. And then h prime is going to be 1, 2. And then j prime is going to be negative 1, negative 6. Okay, so let's go ahead and put that on there. So we're going to go over 3, 1, 2, 3, and then we're going to go down 5. So 1, 2, 3, 4, 5. Okay, and then over 1 and up 2. And then back 1 and down 6. So 1, 2, 3, 4, 5, 6. Okay, and then we're going to connect those. And so that reflection is going to look something like that. Okay, last one. Now, to get g double prime, we're going to multiply everything by 3. So g double prime is going to be 9 and negative 15. H double prime is going to be 3 and 6. And j double prime is going to be negative 3 and negative 18. Okay, so 9 and negative 15. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then negative 15 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So right about there. Okay, and then 3, 6. So 1, 2, 3, and then 1, 2, 3, 4, 5, 6, right up above that other one that was at 3, 5. And then negative 3, negative 18. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, this is not easy to do because those lines are hard to see. Or maybe it's just me because I have old eyes. Okay. Now we will connect the points here. And you can see that we have a reflection and dilation. And that's it. I hope that's what you got. If you're still having trouble with this, then you can check with me in class. Otherwise, that's it. And I will see you later. Bye.